mixing medical gas standards. A brand new operating room sits ready. The medical gas installation looks perfect. But when the anesthesia machine is connected for commissioning, the probe won't fit. The project grinds to a halt. Why did this happen? When we think of medical gas safety, our focus is typically on preventing leaks. We assume a sealed system is a safe system, passing pressure tests with ease. But what if the greatest danger isn't what's escaping? The most counterintuitive problem is not a defect, but a mismatch. This is a guaranteed failure hidden in plain sight, where everything looks right but is fundamentally incompatible. So what creates this critical design flaw? Think of medical gas standards as different locks. A perfectly cut key is useless in the wrong one, no matter its quality. It's not about which is better, but which ecosystem you are in. These are not parts, they are systems. The world's major standards, DIN, BS, and US, are complete ecosystems. Each dictates the physical shape of the connection, its unique safety indexing, and its specific maintenance parts. Mixing components between them is where the risk begins. The first pitfall is simple. The parts don't fit. A more dangerous risk emerges when adapters create a false fit, bypassing the safety logic that prevents giving a patient the wrong gas. But the danger also extends over time. Months after installation, a simple part needs replacing, but the hospital supply chain is based on a different standard. A critical room is now offline, crippled by a single, incompatible, low-cost part, creating immense operational risk. When a mismatch is discovered, the cost isn't the component, it's the rework. Retesting, recertifying, and delaying the room's opening can consume the entire contingency budget. But the ultimate cost is far greater than money. The ultimate consequence is lethal, supplying the wrong gas to a patient. When systems are mixed, engineered safety guards are compromised, leaving only human vigilance to prevent a fatal error. How can we eliminate this risk entirely? True safety isn't a slogan, it's verifiable system consistency. By specifying and auditing the entire ecosystem from design to maintenance, we build systems that are not just installed correctly, but are fundamentally and sustainably safe.